So this is just going to be a look at our ESD oil powders. So a look at the oil powder market. It's obviously a growing market with about an 8% projected growth rate by 2028. And this is driven very heavily by health and wellness, convenience, and functional applications, among other things. The market right now is dominated primarily by coconut oil powders, soybean, sunflower, olive, and palm oil powders. So very conventional oil powders, typically produced by a spray drying or a plating process. So some challenges that you see in the market today are, number one, the spray drying process is temperature prohibitive. Due to the high temperatures that are utilized, it can accelerate the oxidation of oils. And as Kathy had touched on already as well, freeze drying is utilized, but that is pretty cost prohibitive. So even though it is lower temperature, it's a little bit harder for scalability in that sense. And then plating is also a very limited technology in regard to the oil loading that you are able to achieve with that process. It really caps out at very low percentages. So the processing and formulation challenges and limitations that we're seeing contribute to the limited market availability of unstable oils and oil-soluble vitamins in dried format. So Fluid Air created their equipment, and we utilize that equipment for a solution to that problem. So the ESD solution, as again, Kathy did mention, the electrostatic dehydration combines low temperatures with a nitrogen environment, and then superior encapsulation due to the electrostatics. So this combo facilitates the creation of a better encapsulated oil powder with enhanced stability both during processing and throughout the oil powder's shelf life, in comparison to a traditionally spray-dried oil powder. So now with this technology, we are able to create solutions that offer the market dried versions of unstable oils and actives such as polyunsaturated fatty acids like DHA or EPA, or fat-soluble vitamins like vitamin D, all while being a sustainable and economical process. So we did acquire this equipment back in 2019. And since then, our lab has worked very diligently to understand and perfect key factors that need to be taken into consideration to create a quality oil powder. Starting with number one is formulation. So we've focused on developing a wide range of oil powders, typically between a 50 and 70% oil load. But we are able to go lower than that and have really tried to push the boundaries to go higher than that, achieving oil loads up to 85%. And all of those have been created on a diverse range of carriers. And we also have experimented with various non-conventional carriers to really push the boundaries and identify our limitations and optimal oil plus carrier combos for our application. And much of this does boil down to the need to have enough encapsulating material that is available to coat all of the oil droplets. So with this technology, we're able to push those upper limits higher due to the enhanced ability to really pull the carrier to that exterior of the droplet and form a productive coating over the oil. So once that oil powder formula is vetted, following that is a focus on the emulsions. Without a strong emulsion, you will have a difficult time creating a quality oil powder, no matter what spray drying technology is utilized. So for us, our team has conducted extensive testing and troubleshooting to identify the necessary steps and processing techniques to utilize this equipment for the purpose of oil powder production. So we pay very close attention to the emulsion droplet size of the material going into the dryer. And essentially our goal is to create a very small oil droplet for emulsion processing and stability, with the intention to have that oil droplet size maintained when that oil powder is rehydrated or reconstituted in aqueous solution or whatever that final application may be. So once that formula and emulsion is fully vetted, then we can take a look at processing of the oil powder. So our team has spent years learning the benchtop equipment for R&D work to gain insight on its scalability to pilot production. So our team works very closely with our operators, and both teams really maintain a constant feedback loop in order to optimize our success rates out on the production floor. So when we initially got this equipment installed, we invested several months of trial and error to get it to function as needed for our application. And Fluid Air helped us tremendously throughout that entire process and was very dedicated to troubleshooting any issues that we saw during startup, and still to this day are so helpful anytime we run into any issues. So ultimately, they were a huge part in our ability to bring these oil powders to full-scale production. And once we made it through this startup phase, we really shifted our focus and learned a great deal about the equipment and our lab-vetted formulations throughout this entire process. So we began to recognize some distinctions between the lab scale and production dryers, and identified areas that needed more attention, such as our formulas or the processing techniques that we thought we had figured out in the lab. One particular example of that is utilizing this equipment for the drying of unstable oils such as DHA. So despite the equipment operating at a lower temperature, with our formulas and some of the oil loads that we are shooting for, those materials still require very close monitoring of outlet temperatures during the drying process to maintain optimal stability and quality. And with those critical control points in processing that Kathy identified, it really helps us to maintain constant outlet temperatures that we are shooting for. So I am going to turn it over to Ariel, who is our QC manager, for a couple of slides just to touch on the enhanced stability and how it applies to some of our oil powders.
Hi, thanks, Michaela. So to start, you guys probably know by now, ESD technology provides low outlet temperatures and an inert environment, and then the electrostatics contribute to superior encapsulation, all things that are actively contributing to the overall stability and quality of the powder that's coming off the dryer. With these capabilities, they're all playing, like I said, like an important role, especially in oil powders with sensitive oils. Rancidity is directly influenced by heat oxygen, mainly in terms of processing off these types of equipment. So it makes it challenging to spray dry oil powders without actively contributing to oxidation of the oil. And we gauge oxidation by peroxide value testing in our lab. And we are taking samples, composite samples, directly off the dryer and testing immediately. We also have some pre-oil testing that we'll complete beforehand just to see where we're starting at. But we were able to run a study using 2 different trials on 2 different sets of equipment. We ran something on a traditional spray dryer and on our ESD technology. We ran a 50% flaxseed oil powder, and as you can see, the heat and the oxygen exposure from the traditional did contribute to a higher peroxide value directly off the dryer. And we're always consistently working on lengthening the shelf life of our powders. And recently we've gained the ability to conduct rapid oxidation tests. So this is an instrument that basically accelerates shelf life of a product in the matter of hours. It has increased oxygen, pressure, and heat. And through that, we can get results very quickly, and then we can correlate that data to produce an estimated shelf life of what the powder is that's coming off the machine. And just a stability highlight for you guys, we've run a lot of CBD oil powders, and CBD, in this case, we used a CBD isolate. We were actually able to, the exact CBD isolate that we used in a couple of these powders, we retained a sample of and conducted a study of the CBD potency few years later. And inherently in nature, CBD degrades, just exactly the same reason that oil powders or oils or any other things would degrade. So that first bar graph right there, and then the graph next to it is kind of showing where all those are from. But the CBD isolate started out at 992.86 milligrams per gram. And in 2023, it tested at 851.28 milligrams per gram, just proving that, yes, it's degrading over time as it normally would. And in an encapsulated oil powder, both of these produced on ESD equipment. You can see that we have almost no changes in that CBD, which just kind of proves that our emulsion and our encapsulation was stable enough to not allow oxidation or rancidity or anything to affect that CBD potency over time.
And another product I would like to highlight on this webinar is our newly launched canola oil powders. So we currently have two options to offer. One is a 50% oil load on soluble tapioca fiber and gum acacia, and the second is a 70% oil load on soluble tapioca fiber and modified tapioca starch. So these oil powders are produced with sustainably sourced omega-3 canola oil, and our supplier created this oil essentially by adding microalgae genetics to canola, establishing pathways within that seed that are able to convert its native fatty acids to omega-3 fatty acids such as ALA, DHA, and EPA. So the oil does contain 7 different omega-3 fatty acids, which you can see up on the screen. And creating an oil powder with this material would be difficult on a standard spray dryer, again, due to that high temperature that you are subjecting that material to. So the ESD equipment really allows us the special opportunity to be able to take this product and deliver a powdered version to the market. Our system helps to maintain the integrity and the beneficial fatty acids of the oil. And the 70% oil that we have to offer delivers up to 175 milligrams per gram of total omega-3 fatty acids in just 1 gram of oil powder. Both of these oils or oil powders, they are non-marine and plant-based. So number one, we have a very consistent supply and reliable supply of omega-3, and we are not relying on the ocean or the fishing seasons to be able to get material in to create material that can fortify products in the food and beverage market. So on top of that, it does have superior sensory characteristics. So it is going to be void of strong marine taste and aroma, unlike fish and algal DHA oils. So it has very mild sensory characteristics, allowing for minimal organoleptic impact in a final formulation, and is going to be very well suited for beverage applications, especially in comparison to a traditional fish or algal DHA oil powder, which are very difficult to mask the flavor of. They're just very strong and marine-like and typically give a unpleasant flavor to a final formulation. Have a standard catalog of offerings. We do routinely take on custom development requests from our customers, and we're more than happy to work with customers to find the ideal oil powder solution for their application. So we've developed powders tailored to a variety of applications. We've worked with oil powders going into dairy alternatives, dairy-free creamers, ready-to-mix beverages is a lot of what our customers are using some of these in, as well as capsules, tablets, bars, and pet food, like I had mentioned. So, and then if anybody has any questions or interest in our offerings after this webinar, they can contact us by the information on this page. Otherwise, on the earlier intro slide, our team's contact information is available, and you can feel free to reach out to any of us directly with any technical questions that you may have or application questions on our products.